to my channel. In this video, I'll be walking you through mathematical induction. Mathematical induction. These are the outline for this video. The first one is definition of what mathematical induction. The step in involving. The step involving in solving mathematical induction. The step involving in solving mathematical induction. The third one is what? Example on mathematical induction. Once again, this is Further Solutions Academy. Further Solutions Academy. Encourage us more. Just encourage us more by help us to share our videos, and also if you have not subscribed, help us to press your subscribe button as you have done, as you are watching any of our video. Please subscribe to it. It's going to be helpful. Now, I want to be walking you through induction, mathematical induction. Now, if I should talk something about induction, is a mathematical statement that check whether the statement is true or not. Now, if I'm to define it, my mathematical induction. Now, the mathematical induction is very useful. It's very useful. It's very useful in providing statement. Providing statement involving all positive integers. Now, that is all about what I can say about now we always deal with what positive integers, and also it just like what is a statement, just to show whether something is correct and what is not correct. Now, I can't say much about it for now. Now, if I should move on to the steps in mathematical induction. Now, the first one is, I'm now on step. Proof that the statement is true when n equals to 1, or some others positive integers. Now, that is number one. We prove it when n is equals to 1. I mean, after proving it, you can also prove for another integer like 2, like 3, and so on and so forth. The next one, number 2, we assume that the statement is true for n equals to k. That is very, very important. Where k is any positive integers. Now, let me just put integer. Now, the next one, the third one, I will not say that one. From that statement, in k, which is in 2, remember we got 2. Sorry, this place. From that statement in this assumption, now above, let's just put above. Okay, from that statement above, Prove that what? Prove that n. Prove that what? Prove that okay, okay, okay. Prove that the statement. Prove that the statement. Prove that the statement. The statement is okay. The statement must be true. Must be true for n equals to k plus 1. For n equals to k plus 1. That is all about the step. Once you can achieve this particular statement, we have done our what? Our mathematical induction. The first thing we do, we prove that what? That the statement is true for n equals to k after or some other positive integers. After we have done that, assume that what? The statement is what? True for n equals to k. When we have done that for okay, and where k is any positive integers. The next one then, which is the last one, from the statement, this particular statement, which is in 2 above, prove that what? That the statement must be true for n equals to k. That is all about mathematical induction. Now, it's a very, very nice concept in mathematics, but just help us to make a argument, the statement, just help us in proving statement. Now, if I have example now, if I have some problem this way, I have this problem to work on. Okay, I have this problem. For instance, okay, I have a particular statement here. Prove by induction that 1 plus 2 plus 3 plus k plus n equals to n all over 2 bracket of n plus 1. Now, this is a very good example of what? Or question on mathematical induction. I'm asked to prove this statement that what? Prove by induction that this particular statement LHS, this is LHS, is equals to what? RHS. Now, how will I prove it? Solution to this problem. Now, I will show you some instance so I will be able to see it very well. Now, I want to work on the integer. Assume, the first thing I will do is that assume n equals to 1. Now, at my n equals to 1, I will have my 1 equals to what? Everywhere 1 all over 2, 1 bracket of 1 plus 1, which is equals to what? 1 equals to, this is going to be 2. 1 all over 2, 2 all over 2, which is equals to 1. Now, 1 is equals to 1. It is true that what? N equals to 1. Because side A is equals to side B. Now, let me show you another instance. I will also assume that what? Another integer, n equals to 2. Now, at this n equals to 2, I will have 1 plus 2. Now, I will now move on to what? Can it be equals to 1 all over 2, bracket of 2 plus 1. Now, it means my n equals to 2. This is going to be 3. Now, I will be having this will cancel this. Now, this one will be what? 3. Can you see that what? 1 plus 2 is equals to what? 3. 3 is equals to what? 3. It is true that what? That n equals to what? 3. Now, I'll move on again. If I want to show that I really know what I'm doing, assume n equals to what? 3. What I will just do is that 1 plus 2 plus what? 3. Can it be equals to 1 all over 2 bracket of 3 bracket of what? 3 plus 1, which I'll be having what? 3 plus 1 is 4. 4 into, I'll be having 3 times 2, which is going to be what? 6. Sorry for those that are going to be 6. Now, can you see that this one, it will be what? 6. This plus this is going to be 6. It is also true. Since all these statements are very, very correct, I will now assume that what? Assume n equals to k. At this point, my n is equals to k. It means be 1 plus 2 plus what? 3 plus what? Dot 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 plus k. It will be equals to what? 1 all over what? 2k bracket of what? K plus 1. That is just it. Now, I don't need to so much here. Since these are correct, it means this also will be what? Correct. It is true that what? N equals to k. Now, this is where I will now need to do some mathematical illustration. Now, I will assume that n equals to k plus 1. This is where you have to be very, very careful. Now, at this point, how will I establish this? Now, I can only establish that when my n equals to what? K plus 1. I will now say that what? My side A will be k plus 1. Now, it means I'll be having k plus k plus 1. Don't forget that everything that is here become a what? K. Everything that will become a k plus 1 can now be equals to, anywhere I see n, it will represent by k. 1 all over 2, k plus 1, and what? Bracket of what? K plus 1 plus 1, k plus 2. Now, I will now start my what? My maths. I will now start on now. I can now use any side. Now, if I should this is the statement I want to prove. These two statements, that this is equal to this or this is equal to this. I can decide to from LHS. Now, what is my LHS? This is my LHS, my left hand side. K plus what? K plus 1. Now, that's what I want to work on. Now, I will now move on by having what? What is my k plus 1? My k, note my k, this is my k, this is my k. It means this, and now I'm now be having what? I have, which is my k, this my k will produce me what? Sorry, it will produce 1 all over 2k bracket of what? Sorry, okay, bracket of k plus 1, that is this my k, plus the k I'm having, k plus 1. Now, that is this is the k, and plus having 1. Now, I will now do a bit of mathematical things there. Now, what is going to come on here? I will have, I can say that what? K, bracket of k plus 1 plus what? 2 bracket of k plus 1 divided by what? 2. What am I doing? I'm just doing my normal fraction. Now, at this point, I want to factor out. I want to factor out something very good. K plus 1 is common. K plus 1, big bracket of what? K plus what? 1. That is k plus 2. This is from all divided by what? 2. Now, this is just for my what? LHS. Can it be equals to what I'm having here? Can you see that what? This is equals to this. This is equals to this. It means k plus 1 bracket of what? K plus 2 all over what? 2. It will be equals to 1 all over 2 bracket of k plus what? 1 k plus 2. Now, LHX equals to what? RHX. Now, it means it is true that what? N equals to K plus what? 1. That is my final answer. That is what? The statement is already been proved. It has been what? It has been proved. That is all about it. The first thing I do, I first test for what? N equals to 1. I also move on just to establish the art very well and how to play with testing. Test for n equals to 2 and also test for n equals to 3. After that, I also assume that n equals to what? K, which I have what? Everything that is here. Since 1 is correct, 2 is correct, 3 is correct, also n equals to K will be correct. After that, I assume that what? N equals to K plus 1. Now, this is where problem comes from. This is my K. K plus what? 1. K plus 1. This is my what? LHS. And everywhere on that side, anywhere I see N, it will be represented by what? K plus 1, K plus 1, which is very, very, very correct. Now, I will now move on. I'm coming from what? My LHS. This is my LHS. This is my what? LHS. Since my LHS is what? Is standing by, it means K plus what? K plus 1. What is my K? My K is this. In this statement here. Now, I will now put the statement which is going to be K plus what? Plus this. I will now do my normal fraction and I will go and I have this and now. Since LHS is equals to RHS, it is true that what? N equals to K. Now, let me give one more example. Okay, let me give one more that will kind of be of help to us. So when you are solving, anytime you have induction, just be happy about it and just move it up. It's going to be of help. Now, if I have a question this way, okay, I have a question this way. I have this type of problem. Okay, I have a type of this question. Okay, proof by induction that 1 squared plus 2 squared plus 3 squared plus running to what? By running to what? N squared equals to n bracket of n plus 1 n plus 2 bracket all divided by no, let me just put this one. N plus 2 bracket of what is the question? Okay, thank you. 2n bracket of 2n plus 1 and bracket all divided by 6. Now, I want to prove this statement. Solution to this one is very simple. Where am I starting from? I will start from what? To prove on my integer side. Now, assume that what? N equals to K. N equals to 1. Now, when I assume n equals to 1, I will have what? 1 squared equals to what? 1 bracket of 1 plus 1 bracket of 2 bracket of 1 plus 1 divided by what? 6. This one will be 2. This one will be what? 3. Which is what? This will be what? It won't be any change, which can be half 6 all over 6, which is equals to what? 1. Okay. 1 is equals to 1. It means my 1 equals to what? 1. It is true. It is true that what? My n equals to 1. Let me move on so that we'll be able to see very well. Since 1 is correct, let's try maybe 2 will be correct also. Now, assume that what? N equals to 2. Now, at this point, I will move on by having 1 squared plus what? 2 squared. Can it be equals to 2 bracket of 2 plus 1 bracket of what? 2 bracket of 2 plus 1 all divided by what? 6. Now, surely this one here 1, here what? 3. This one will be what? 3. 3 will cancel 3. Now, since I have that, this one will be what? 2 plus what? 4. Can it be equals to this one will be 5? This one will be 5. 5 is equals to 5. Now, it is what? True that what? N equals to what? 2. I can now run to what? To K. I can also run the system to what? To K. Now, if I should run it to K, okay, assume N equals to K. Now, since 1 is correct, 2 is true. Now, I will now move on by K plus 2 plus 3 squared plus what? Dot dot N squared. K squared can be equals to what? K bracket of K plus 1, 2K plus 1 divided by what? Now, since 1 is true, 2 is true, therefore, it is true that what? N equals to K. That is very, very correct. Now, I will now move on by having the next one. Assume N equals to K plus 1. Now, this is where the sensitive part of it comes from. Now, when I assume that N equals to K, I will now move on by having, look at it, 1 squared plus 2 squared plus 3 squared plus what? I run into what? Now, at this point, I'll be having K squared plus what? K plus 1. Please take note of that. Also squared equals to, because the other one, it was K plus 1 and there won't be any problem. Equals to, anywhere we see what? Anywhere we see our what? Our N, it will surely be what? K plus 1, which is what? And also K plus 2, and also this one will now be what? 2K plus what? 2 plus 1. Okay, I have to rub. It's getting smaller and I have to be very careful with that. Okay, can it be equals to K plus 1, K plus 2? Now, this one will now be what? 2K plus 1, which is 2K plus what? 2, which is going to be 3. Yes, it's going to be 3. Can it be divided by what? 6. Now, how do I go? I can use any of the side. I can decide to use any of the what? Of the side. Any one that I feel like to use is good to go. Now, what is very, very important is what? Side A must be equals to what? Side B. Now, how do I start? From LHS. I can use my RHS if I feel like. I can use it, but let's start from my LHS. Now, my LHS is what? I'm having what? This is what I'm using now. I want to use this statement. This is what I'm using. Now, what is my K squared? My K squared plus what? K plus 1 all squared. That's what I want to work on. Now, what is my K? K squared is what? Is everything that is here, which is to be what? K plus what? Plus K plus 1, 2K plus 1, all divided by 6. That is mine. All divided by 6. Now, plus K plus 1 squared. What is my K plus 1? I will have my what? K plus 1 all squared. Now, that is what I will do. Now, I want to rub this on the board. Now, since I have that, I will now continue by having what? I want to factorize. This is a fraction. This is all over 1. Now, I can now say that what? With the help of my fraction, I can say that K, don't expand. I will advise not to expand. I'll be having now k bracket of k plus 1 and bracket of 2k plus 1, 2k plus 1. Okay, okay, this one will now be what? Plus what? 6k plus 1 squared divided by 6. Now, since I have this, I will now move on by having, okay, if I should expand this, if I should expand this, is there anything here? This one, this one. Now, I can see that what? My k plus 1, I factor it out. Left with what? K bracket of 2k plus 1 bracket of 6k plus 1 divided by 6. Divided by 6. Now, if I should factorize, okay, let me just, is there anything I can also factor out here? Okay, let me just do a bit of expansion. Now, at this point, I can expand 2k squared plus k plus what? 6k plus what? 6 divided by 6. This one will be what? 7k plus 1 bracket of 2k squared plus what? 7k plus 6 divided by 6. Now, if I have this, I can now have this. If I should factorize this rubbish, I can have what? K plus 1. Now, this and this is 12. What can I multiply to get 12 and 3? Which is going to be what? 3 and 4. 3 and 4 will be up to that level. It means I'll be having, okay, 3 and 4. Sorry, I want to quickly factorize. I have a 2k squared plus 3k plus 4k plus what? 6. I want to group them into 2. What's common here? I have k is common here. I have 2k plus what? Plus 3. What's common here? I have plus 2. I have 2k plus 3. Now, it will be what? Now, I think I will be having this and this is common. Now, I will be having bracket of what? K plus 2. I'm factorizing it already. Now, this will also be 2k plus what? 2 plus 3 other. All divided by what? 6. That is, okay, that's equals to that. Now, if you are to do the same thing to this side, if you are to do the same thing, you will get the same. Now, since this is equals to this, I think you can easily see that now. That's open the bracket, expand it up. If you do a bit of expansion on this one, on this part, you will see that what? This is my LHS. Now, if I want to work on my RHS a bit, you can do the same thing to RHS. It means you do a bit of expansion on this part of it. Now, which is going to be what? I have the same thing, which is going to be 6 and so on and so forth. Since when you expand this, you can expand this on your own. You see that you have this. You see that you have that. Since I have that, I will now say that what? It is true that what? N equals to what? K plus 1. That's my final answer. Now, this is all about induction. Mathematical induction is a statement. It's a very, very good concept of mathematics. Make sure you follow us up. Any topic you are having problem with, just find yourself here in mathematics or physics or chemistry. Once again, further solutions academy. Encourage us more. Help us to share and also subscribe. Help us to share and also subscribe. Thanks for watching. Thank you so much. Thanks.